Hello everybody and welcome to the brand new Q-SYS Architect Training. Now what we're going to learn in Q-SYS Architect is not how to program Q-SYS systems, but we're going to learn about how to design Q-SYS systems. And along the way we're going to learn about the actual architecture of the entire Q-SYS platform. We're going to be talking about audio, about video, about control, and we're going to be designing a number of different systems similar to the ones that you see along the bottom of the screen here. Now let's firstly look at the table of contents and let's look at what we're actually going to be covering here. So we're going to start off with a look at what is Q-SYS. So if you're completely new to Q-SYS, don't worry about it. You are in the right place, okay? We're going to start off up here just learning about the entire Q-SYS platform from a high level and seeing how it fundamentally is quite different to a number of other AV technologies that are out there. And we're going to see how that's going to make things very easy to design, easy to deploy, and to maintain. Then what we're going to do is we're going to go along learning about how to design different systems. So we're going to start off building a fairly straightforward system, and in that section we're going to learn about some of the fundamental principles. For example, how audio peripherals connect, how we can use AV and USB bridging to make the room geography and the room connections very, very straightforward. And then from there, we're going to start to scale up. You're going to see that with Q-SYS, scaling up is pretty easy to do. We're going to start off looking at some high impact spaces, looking there more about Q-SYS control, video distribution, and other kind of technologies that you're going to want in those kind of spaces. We're going to go bigger still. We're going to look at some more advanced systems, look at when you need to use multiple networks, maybe network segregation, cloud, look at some really high power systems and some considerations you might want to make there. And then we're going to look at centralization. So here we're talking about the biggest Q-SYS systems, or maybe we're talking about lots of small systems but all running in a centralized way with centralized processing. Talk about the pros and the cons of that approach. And of course, make sure you pay attention because there is going to be an exam at the end, okay? Let's start off with a look at the whole Q-SYS platform architecture. Take a look at this. Here we've got a map of the whole Q-SYS AV platform, okay? And this is kind of a conceptual map of how the different software and hardware parts of Q-SYS relate to each other. Now, the first thing I want to point out is that Q-SYS, even though it's going to be doing audio and video and control, these are all done in a single cohesive way. And that's quite different to the way the AV industry typically works. Typically in AV, we're going to have one set of products for, say, audio. Let's say you want to do some audio processing. Traditionally, you would go and buy an audio processor that is going to be doing that on a hardware level. It's going to have hardware inside that processor designed for audio specifically. But of course you're going to want some kind of automation, some kind of control as well. So then you go and get a control processor and you've got to tie that into the audio processing, all right? And then of course you might want video extensions, video distributions, maybe all sorts of other things. These are probably going to come from multiple manufacturers. But even if they come from the same manufacturer, they're probably not natively interoperable. They're different hardware platforms, different software platforms. And that's where Q-SYS is very different. We've got this holistic AV platform, okay, that includes all of the I/O, multimodal I/O, so that means audio, video, and control input and output. We've then got a cohesive operating system that deals with all of that at a software level. So it deals with the audio, the video, control, processing in software. And then we have the cloud, which means that all of this is available from anywhere. Now, let's talk a little bit about this, about some Q-SYS products, because again, unlike many other manufacturers that will make a number of different products, they're all going to work differently. With Q-SYS, that's not the case. Okay, we're going to talk first about processors, and then we're going to come and talk about some of these other things, which we call Q-SYS peripherals. Let's start with the processors, okay? And take a look at this. Here is a number of Q-SYS core processors. And a Q-SYS core processor is not the same as many other DSPs or control processors that you might be familiar with. This is a processor which does everything in the software layer, the audio, the video, and the control. And you're seeing behind me here a number of different models, of course, right? Some smaller ones, don't look so small right now with me shrunk down, but some smaller ones, some bigger ones. But the important thing to realize here is that these are all fundamentally the same. They're all built on the same architecture, okay, this IT standard architecture. And what that means is these are all essentially IT products from a hardware standpoint. They all run Intel processing. And then they have this software layer. They all have the same audio, video, and control engine. Okay, doesn't matter if it's a small one or a big one, it's the same software, and they also use the same software that a programmer would have to build a system. Doesn't matter if it's a small system or a big system. Where these differ is in the amount they can do, not so much what they can do. They can all do the same things, but it's a case of scale. Do you want to just do a small, simple system, or do you want to do a football stadium or an airport or anything in between? Now, let's break that down a little bit, because there's basically two main categories of Q-SYS processor, which are going to be good for different things. Now, this breaks down to, firstly, appliance cores, okay, and server cores. An appliance core, firstly, it's going to have a lot of power. All of our cores have a lot of power, but these are typically designed for a single space or maybe a larger space, like a divisible room, something like that. But typically, you're not going to be doing, let's say, a whole floor of meeting rooms or a massive transportation system on an appliance core. Server cores, they're a little bit different, okay? They are all about power and scalability. That's really their USP, if you like, with the server cores, the bigger ones. Now, also, they differ in the input and output capability. So because appliance cores are designed to be, usually located in the room, probably connected physically to a few other audio, video, control devices, they've got integrated I/O, as we'll see. For example, analog audio, USB connectivity, HDMI connectivity. Server cores, no integrated I/O, network only. They're designed to be placed in a comms cabinet, in a server room, connected to the network, and all of the input and output is going to be on the network for maximum scalability and flexibility. And an AV-centric form factor on the appliance core. So they're designed to be rack-mounted, they're designed to be going into maybe a smaller space. The server core's usually going to be bigger, and they have what we'd call an IT-centric form factor. So they're going to be deeper, designed to go into comms cabinets, and also they're going to have maybe features like redundant power supplies that you typically find on larger pieces of hardware. Now, from a software perspective, the real benefit of having Q-SYS do so much in the software layer, no matter what core you're running it on, you're going to find that you have a huge amount of flexibility. And here I'm just showing on the screen a number of features which are typically considered hardware features in the AV space, but in Q-SYS, as much as possible, we like to do things in the software layer. And that really means the benefit to you is flexibility, okay? You can do any number of things here on all of these different cores without having to buy additional cards, without having to buy additional peripherals in many cases, and also getting new features all the time through software updates. A good way to think of it is a little bit like a smartphone. In the past, we would carry around, let's say, a notepad and let's say a phone and an MP3 player and a camera and things like that. Now we have one single piece of very powerful hardware that can do all of that in the software world. And that means that when a new app or something comes out that you want to make use of, you don't have to go and buy a new phone. You just download that and install that. And Q-SYS is very similar. All of our software releases always include new features which every core that supports that software release can make use of. Now, let's talk a little bit about the processing power in some more detail. Let's put some numbers to that, okay? With any Q-SYS core, and here's one right here, one of the smaller ones, some of the key things we're going to be thinking about are going to be peripheral count. So we're going to be adding in Q-SYS peripherals to these. And we're also going to be thinking about some of the key audio features typically, like, for example, acoustic echo cancellation. That's one of the more resource-intensive audio processes that you can do. And also, we typically look at the amount of network input and output capability that that processor has, okay? We don't have to remember these numbers right now, so don't worry about that. We're going to get into the detail later. But let's just say that that is one chunk of processing. Okay, this is one of the smaller cores. Let's say that's 1x processing. Just to give you an idea of how far this can go, if you take that and you say, okay, we're actually going to look at how that compares across the lineup. depending on what core you decide to go with, you're going to be able to choose the right core for the processing that you need. Okay, everything from 1x processing all the way up to something like 40x processing for a very, very powerful system. And we're going to cover the whole gamut of that in this training. Now, that's processors, okay? Let's have a little look at Q-SYS peripherals, because here we're going to be talking about amplifiers, loudspeakers, video devices, also control devices, any peripheral that you can think of when it connects to a AV system. Typically, again, these are all very different devices that all work in very, very different ways. But with Q-SYS, much in the same way as the processors are all built on this single software-hardware foundation, it's the same thing with the peripherals. It doesn't matter if, for example, it's a camera or a 8-channel amplifier or a PoE loudspeaker. Typically, we would think of these as completely different categories of product, and they are, but in Q-SYS, on a quite low level, they all use the same communication methods, they all speak with the core in the same way, and the core is always managing all of that video, all of that audio, and the control data. Doesn't really matter what Q-SYS peripheral you're using. So that means you as a designer, you get to deal with all of these peripherals in the same way. You can think of them as similar devices rather than as completely different categories of device that need different approaches to make the system work. Let's look at that in a bit more detail here. So if you think about our core processor, what is that doing? Well, it's doing the audio, video, the control processing, and it's also doing monitoring and management. Well, monitoring and management of what? Well, that's where the Q-SYS peripherals come in. And here I've just thrown in a bunch of different things, right? We've got an amplifier, we've got a touch panel, we've got a camera, we've got a microphone. We're going to learn all about that later on, but these are all native Q-SYS peripherals, which means that the core talks to all of them, manages all of that traffic, and even down to the control and monitoring here, it's managing their firmware, device discovery, device configuration, okay? The programmer has a very easy job because the programmer doesn't have to go into these and configure them to talk to the core. They actually just put a single file on the Q-SYS core, which we call the Q-SYS designer file, and that actually tells the whole system how to operate. The core then basically takes over these devices and tells them what to do based on what is in the designer file. So you just got this single point of contact over here, even if your system gets really, really large and has a lot of different peripherals. Let's focus firstly on the audio peripherals. Let's talk about amplifiers and loudspeakers and also any other Q-SYS audio peripheral, including I/O devices. Now, the way this is going to be working is partly on the core and also expanded via the network, depending on what model of core you have, okay? Let's look over here. So I've got my Q-SYS core and it's got some local I/O. So this model has got some USB audio I/O. It's also got some analog audio as well. But the vast majority of what we're doing with audio, as we expand our system, is going to be via QLAN. All right? Now QLAN is the set of protocols that Q-SYS uses on the network. And this actually encompasses everything Q-SYS does on the network. The important thing to realize is that the core manages all these connections for you between the different devices. Now, that also includes discovery, video, other things. But here, let's just talk about it from an audio perspective. So we've added in some audio peripherals, and the important thing to realize here is that all of the audio in the system is going to go back to the core and then back out to whatever device you want to send it to. And the core is going to manage all that for you. Okay. As designers, what we need to be thinking about is what peripherals do I need to do the job I want to do in my system. But it's important to understand how this stuff works on the back end as well. So of course, QLAN used between Q-SYS peripherals, but of course we want to add third-party devices as well. So all the Q-SYS cores also support Dante, also support AES67. And again, this is a great example of us adding features via software, okay? So the Dante doesn't require an additional card, doesn't require a different SKU. All of the cores feature Dante, and you can choose to add more if you want to, if you've got a bigger system perhaps. And again, that's all delivered via software. So no need to add in different cards or get screwdrivers out to make Dante work. And then, of course, we're going to use that to add in third-party devices, perhaps some microphones like you see here. All right, so that's audio. Now, what about video devices? How does this work? Well, with video, particularly in a conferencing setup, there's really two sides to that coin. There's really two different types of video that interoperate depending on what we're doing. Firstly, we're talking, of course, about conferencing, okay? Conferencing video. And in this situation, what we're trying to do is get video from a camera to a conferencing device, usually a conferencing PC running something like Teams or Zoom or perhaps Google Meet. Now, traditionally, this is all done using USB cables, but we're going to deliver all of that through the Q-SYS as well for maximum scalability and flexibility. We're going to get into it more later, but what we need to know for now is that the cameras are network devices like all Q-SYS peripherals, and we're sending that video traffic to another Q-SYS peripheral, which is going to then just bridge it to USB at the very end, okay? And of course, the maximum benefit to this is that we can have multiple cameras. We could have 1 or 2 or 10, it's all good, okay? We're switching on the network and we're maintaining a single USB connection. Now the other side of video is of course content video. Maybe we want to plug in a USB-C or an HDMI and get content onto a screen. So for that, we're using a different Q-SYS peripheral, something from the NV series, which we'll talk about later. That's going to receive HDMI or USB-C. It's then going to encode that and it's going to send it to a decoding device. And then you're going to get HDMI on the output. And of course, again, the benefit to this whole network transportation is that we're going to be able to do multiple inputs to multiple outputs. And of course, just like with the cameras, all of this can scale up as big as you need. And you just need to make sure that the core you've chosen can handle all of that. Speaking of the core is always involved in this. Even though video doesn't always go to the core, like audio does, the core is always managing all of this. So again, we're only interacting with the core if we're setting up a system, and it is actually talking to all these devices, making sure all the streams are going to the right place. So still that single point of contact to manage everything. So there we go, we've had a look at Q-SYS products, some hardware. Let's also talk about the rest of the platform, because like I said, we've got the I/O, we've got the platform OS that's running on the core, and then we've got the cloud. And the important thing to realize with any Q-SYS system is that the core knows everything that's happening. Okay? It knows about every single device, its status, what it's doing, its history, or its logs, because all of that is always coming back to the core locally. Every Q-SYS system does this, okay? But because we've got that single source of truth in the core, this single thing which knows everything that's going on, it's very, very straightforward for you to make all of that available through the cloud. And this is using something we call Q-SYS Reflect. It's that top layer of that Q-SYS solution. And here you're going to get all kinds of different data from your core going into Reflect. And of course, that means that every single system you have can be made available remotely if you choose to do that. This is included with every Q-SYS system. We'll talk more about it later, okay? So there we go. We've got the whole stack there, the cloud, the OS, all the way down to the I/O, and we haven't even talked to this point about all the Q-SYS partners and the Q-SYS open platform for control. We'll get into that more later when we talk about control. So there we have it. There's our introduction to the Q-SYS platform. And before we completely move on, I do just want to point out that you're going to find Q-SYS in a number of different verticals. Okay, corporate AV, higher education. We're actually going to be focusing mostly on those in this presentation because that's typically where you're going to find systems that use all of what Q-SYS is capable of. But also, of course, in entertainment. Okay, could be theme park, could be a cinema. That's actually sort of where Q-SYS began, is in these large complex systems. And of course, you've got a number of other verticals as well: transportation, sports arenas, government, anywhere where you need audio, video and control, you're going to find Q-SYS managing all of that under one roof. Next up, let's see what we need to understand to actually design some systems. So next, we're going to be looking at building a system. But what are we going to be building? Well, take a look at this. We're going to work on a fairly straightforward conference room, okay? This is a room which is going to need bring your own device. It's going to need, of course, microphones, camera, some kind of room control, a touchscreen to deal with all of that. And what we're going to do here is learn about basically how we can build this nice, simple Q-SYS system. But along the way, we're going to learn about some fundamental Q-SYS principles that enable this to work. So, Firstly, I think we should talk a little bit about the audio side, the microphones, and of course loudspeakers as well. So coming back to here, we talked about how QLAN is managing the connection between all our peripherals and between our Q-SYS core. Let's talk about one of those peripherals now. Let's talk about microphones. Very important in a conference room, it turns out. Okay, here it is. This guy here, this is the NM series network microphone. Okay, pretty much everything starts with an N. Really easy to remember because everything is network based. And this is a beamforming intelligent microphone that is native to Q-SYS. Okay, so just like everything we've talked about, to enable an NMT1, you as a designer, you don't have to think about anything more complicated than the network connection. It's a PoE device, you connect a network cable to it, you have that on the same network as your Q-SYS core, and all of the audio from the microphones on here goes back to the core where we do beamforming, we do echo cancellation, and of course we've also got this nice control surface on the top. Now let's talk about the audio first. As you'd imagine, it's got 360 degrees coverage and it's got 4 configurable zones, which are 90-degree zones. These are configurable and of course you can enable or disable them as required. For example, here you can see one is disabled, which faces the screen, which makes sense because no one is speaking from that direction who is actually in the room. Let's talk a little bit about the control surface here because this is pretty fun actually. Here we've actually got a bunch of different buttons and lights, and all of this is completely configurable. In fact, all of this can be turned on or off. So you could actually say, do you know what? I don't want to have user control on the microphone. If you do turn it off, all of these just go completely black and you can't see them anymore. And you just have this really nice clean surface. But you can do some very handy things with this. Of course, you can mute the microphone. So you've got mute here, and that will synchronize, as you'd imagine, with your call system and with other peripherals, as we'll see later on. You can also answer or hang up, and that's going to work with Teams, with Zoom, with Google Meet, with Bring Your Own Device. It's also going to work with soft phones, and it'll even work with analog phone lines if that's something that you are still using. And then over here we've got a customizable button. This little blue button, you can make this do anything you want by tying it into the rest of the Q-SYS control system. So have a think about what you might use that for. I thought it'd be nice if you pressed that and it sent like a coffee order or something to a touch panel running somewhere else. That would be really nice. I do have to find someone to make the coffee, but that's a different issue. So that's the control surface, with the exception of one last thing, which is this. You can actually mute the microphone just by holding your hand above it, okay? And that's a nice way to have a sort of touchless surface. If you don't want people touching the microphone, but you still want to give people the opportunity to mute, you can actually disable all of the buttons, all of the controls on the top, and just tell people, hey, if you hover your hand over that, you'll mute the whole system. Everything will go red, and of course then you'll be ready to rock. So microphones, we're going to be adding those to our system, and how many we're going to add, it's going to depend on the room, but I think for the room we saw earlier, probably just 2 of these is going to be completely fine. We are going to need to check how many microphones each core can support, but don't worry about that, we'll get onto it a little bit later. Now, of course, audio in our room wouldn't be complete without loudspeakers as well, so here I want to talk to you about the NL series. All right, I told you this is easy. NM, network microphone. NL, guess what? Network loudspeakers, okay? And here's just a couple of options that we have in the NL series. Here you've got the NL C4, okay? This is a ceiling speaker, 4-inch driver, and this is powered over Ethernet and is also a directly network connected loudspeaker. So with these speakers, you don't have to think about your amplifier. You don't have to think about how your amplifier connects to your processor. Just like the microphone, you connect it to the network, and then you're going to find that you've got a loudspeaker which can receive any audio that you decide from Q-SYS. This supports PoE or PoE+, so remember PoE+ is more like 28 watts, quite high SPL for a meeting room actually, but if you've got a limited PoE budget, you can bring that down to PoE, which is about 15 watts, okay, about half the power, either way. You've also got the pendant over there, also available in black. I would have used that on this slide, but of course then you wouldn't be able to see it. And then you've got the NL soundbar. This is the NL SB42. So this is the same basic idea, except it's a soundbar form factor, and it's also a two-way speaker, so it's got a tweeter and a woofer, and this can be mounted horizontally or vertically. So this is great in a number of applications, actually. You could put this under a screen, you could put it left and right of a screen, you could put them all around the room if you want to, and that is the great thing about products like the NL series, is that you just really don't have to think about how is all this going to connect. It's all just on the network, and the audio you're sending to each loudspeaker is totally software definable, okay? It's not defined by the physical connections, which is something that we're going to see again and again as we build out these Q-SYS systems. Now, there's something else to note. You might want to have physical connections, analog connections as well. Now, your cores are going to support that depending on what core you go for, but if you do want to expand that and make that higher channel count using the network, then this is why we have the QIO series, okay? And these are just some small quarter rack units that you can add into any Q-SYS system, okay? So here we have some of those. We've got the output one, the input one, and one which has 2 inputs and 2 outputs, okay? So it's pretty straightforward. These are analog outputs, and over here you've got analog mic or line inputs. Of course, that supports phantom power. This is a professional microphone connection. Now, you see these also have 2 network ports on them. That's because you can daisy chain the networking if you want. If you put 4 of these next to each other, that makes one rack unit. They mount on a shelf accessory, and then you can have that kind of be like one U, and you can daisy chain the network between them. And that doesn't daisy chain the PoE. Daisy chain PoE isn't really a thing, but you can have one power supply and daisy chain its connection there. You've got a 24 volt power supply, 2.5 amps. That's going to happily run 4 of these, no trouble at all. So we're not going to use that in this design. We're going to keep everything network connected directly rather than analog, but it's an important thing to think about. So there we go. We've sorted out our audio, I think. What are we going to do next? Well, there's another really important thing here, is how we're going to do the connectivity with the camera and with the USB. We mentioned this a little while ago in the introduction, but here we're really going to dive into a very important Q-SYS technology, which is AV and USB bridging. Bringing this whole AV system and making it just easily plug and play into any PC, okay? Now, the reason this exists, the reason it's very important, is that many of the kind of systems we're talking about basically look a little bit like this, okay? Traditionally, we're kind of forced in the AV space to use long runs of USB and HDMI, not just as a connection between one device to another device. That's great. But actually, we kind of have to use them as infrastructure. We have to use them kind of like the backbone for the whole system. Now, this is problematic, right? Because then we need things like USB extenders. Remember that USB's really got a length limitation of about 5 meters on a good day when the sun's shining, right? We don't want to be using that to run a camera a really long distance. But also, they're point to point. So they're actually fine. If you want to have a single camera or a single microphone, and that's USB, that's actually not going to be an issue as long as you can overcome this distance limitation. But typically we want to make some higher value, higher impact spaces. So we end up needing to add a lot of hardware. We end up needing to add things like USB switches, USB hubs, matrices for HDMI, active extenders for HDMI, things like HDBaseT, which then means that you're ending up with well, just a lot of hardware, a lot of power supplies for that hardware. And it's the kind of thing which is easy to list out on a spec sheet, right? Or easy to list out on a job list, on a shopping list. But then when you get there and you're actually installing it, it can be no fun at all, okay? You can end up with a system with a lot of hardware and a lot of points of failure. Now, to be fair, on a small system, this is probably going to be fine. Tell you what, let's have a look at some examples, okay? Let's check this out. So, over here, we've got a small room, right? Let's say this is like a huddle room, like a small baby room. And there we've got a camera and we've got a microphone over there and we've got one PC that's fixed in the room, okay? Now, this is going to work just fine. Yeah, we might have a USB extender, but I mean, one USB extender is not going to hurt anybody. That's going to be fine. And actually, this could be even simpler, right? This may well be something like a USB soundbar with a camera embedded in it. That kind of thing is perfect for these sort of small huddle rooms. That's not where the issue is, okay? That isn't where the issue is. The issue here is when we try and take that approach and stretch it out. This is something that we often do as designers. We go, okay, we've got this big room spec come in. It's got multiple cameras, long distances, large room. Well, maybe we can just take what we did a few months ago, that smaller room, and we can just kind of extend that and stretch it out. Here's what happens when we do that. Okay, so let's say we've got BYOD firstly. So maybe it's still a small room, but now we probably need to have a USB hub close to the laptop. We probably need more USB extenders, okay? The shopping list is increasing. The need for power supplies and things like that is going up. What if we have something like this, okay? Now we've got a bring your own device and a fixed compute device in the room, and we need to be able to use both. Not an uncommon use case, something that a lot of customers want to do. Okay, so now we've got extenders, we've got a hub, but we've also got this USB switcher over here. And it's important to remember what that actually does. Sometimes that's positioned as, yeah, it just means you can connect lots of devices, not at the same time. It's basically the electrical equivalent of somebody unplugging it from the laptop, plugging it into the other device, and then plugging it back into the laptop again. Okay, we can't connect simultaneously, and when we do connect, for example, if this is a Microsoft Teams room, you're going to find that that disconnection as it moves to the laptop is going to cause a lot of errors in your Teams admin console, which are quite right because a load of stuff has just been disconnected from that device. And of course now we've got an increasing amount of hardware, and we haven't even got into what happens when you want to have multiple cameras. Again, increasingly common that we might want a camera for one angle, but what if we have a bigger room, we need a camera that can zoom in, or what if we have a divisible room where we've got multiple cameras across different rooms that need to be able to switch between the rooms, switch between different endpoints. We want multiple endpoints and multiple cameras. Well, for this, we're probably going to move away from the USB domain completely. But before I show you the Q-SYS solution, let's again look at the kind of traditional approach to fixing something like this, okay? So we're going to have here some PTZ cameras, okay? And let's say that these aren't network cameras. We're probably going to have, 3 connections to this. We're probably going to have a control connection, we're going to have a power connection, and we're going to have a video connection. And these are HDMI cameras. So we've got an AV matrix, we need to switch between them, so we've bought a box that's going to do that. Nice. And then we've got some connections here, and because these are HDMI, we've got here some extenders, okay, some active extenders. They probably need power supplies as well. Going into the AV matrix, somewhere we're going to convert that to USB video, okay, so then that's going to go into a USB converter, that's going to go into a USB switcher, okay, but of course in a room like this, we're probably going to have a fairly complex audio requirement as well. So we've got ourselves an audio DSP. We've got ourselves some microphones, okay? That's all going in and out of the AV matrix. And now, how do we control all of this? Okay, well, let's add in a control system, right? There's a control system. It's talking to everything. I think you can see it's got a little bit complicated, okay? Nobody wants to be designing this. Nobody wants to be installing this. But this is the kind of traditional approach to these more complex spaces. So now let's fix all of that with the Q-SYS conferencing solution, which is going to use, surprising nobody, the network, okay? Why are we using the network? Well, of course, because the network can deliver any kind of traffic from any source to any destination. It can do one-to-one, it can do many-to-many, and it can deliver audio, video control, and power with no real length limitations, right? We can run Cat5e, Cat6, 100 meters, no trouble at all, okay? So let's see what we're going to do. Here we've got our in-room PC, okay? And we've got our Q-SYS core. And actually, many of those smaller Q-SYS cores, in fact, all of them, all of the appliance cores, have USB connectivity on board. We are then going to have the network connected to the core, and we are going to connect USB to this compute device. And when this happens, the compute device is going to say, oh, hello, I've had some devices connect to me. The core is actually going to present itself as 2 different devices. It's going to say, hello, I am a standard driverless webcam, which by the way, is certified for Teams, Zoom, Google Meet, etc. And I'm also a echo cancelling speakerphone. Now the audio you're going to send through that speakerphone connection is going to be likely from your microphones after they've gone through processing. And we're going to get audio back, and that's going to go to our loudspeakers, okay? No problem. But what's the video going to be that's coming through this webcam? Well, the video, of course, is going to be from any of the NC series cameras that are part of this system. NC, of course, network camera. You getting it yet? I know you are. So the way this works is the video goes from that camera into the core, where it's seamlessly transcoded into a format friendly with USB, okay? And then the PC is just seeing a standard webcam. It doesn't know about all this other stuff that's going on. So here the benefit is no hubs, no switches, no extenders. Okay, really, really nice. But we're still dealing with a single camera to a single destination. The big benefit here is that if somebody says to you, actually, can you add another camera? Or can you add 3 cameras? Can you add 10 cameras? You have to change nothing. The only thing you have to do is add in those additional cameras and connect them to the network. Okay? Doesn't matter if you have 1 or 5 or 10 or 20, okay? All of those can go into the core, and the core is switching between that video traffic while maintaining a single USB connection here. So still the PC doesn't know anything clever is happening, but it can switch between all of these cameras. All right, that's the benefit to using the network as infrastructure, not USB. Now, what if we want more endpoints as well? What if we want more PCs? Well, instead of adding in a USB switcher, say from here, and switching that into other PCs, we can do the same thing we've done with the cameras, right? We can just add more peripherals to the system. So we're going to add a device that has Q-SYS USB bridging. Many Q-SYS peripherals have this. Also, like I said, many of the cores have this. And now what we can do is it can do the same thing that the core's doing. It can actually receive the same video, and we can have as many of them as we want, and that video can go straight into that PC. Now, the cool thing about this is this means we can have any number of destinations, any number of cameras, and scale this up and down however you need, with no problems with length limitations, no problems with power supplies or additional widgets. And this is why it's so important. Any meeting room you do with Q-SYS is making use of this technology, even a smaller room or a really big, crazy auditorium type room. Now, I also want to show you how this actually works in the software. Even though we're not going to be programming it, we're not going to be covering that, I just want to show you how straightforward this is. So, take a look at this. This is the Q-SYS Designer software. This is the single piece of commissioning software that people use to set up Q-SYS systems. And this whole file that you see here is what goes on the core, and then the core is managing all the peripherals. So this is the single place to set everything up. And you're going to see here stuff that looks quite familiar, right? There's some audio DSP, there's our video flow there, and there's some control happening down here. It's all in the same environment. Now, going back to the video, this is one camera to one destination. Let's say I want to make that 2 or 3. What I'm doing here is I'm dragging extra components from the inventory, which represent real hardware devices. Now, this component in the middle represents the switching on the network. So that's not a piece of hardware, that's representing the switching. And now I can wire those up like that. Now I'm going to add in another peripheral for another USB destination, and just like that, I've gone from 1 input to 1 output to 3 inputs going to 2 outputs, and when I run this design on the core is going to reach out to those real cameras, real USB destinations. They're all going to talk to each other, and it's all just going to work. That's how straightforward it is. Now, before we move off from cameras completely, let's actually talk about the cameras. So we need to think about the hardware here. This is the NC110. This is the smallest model in the NC range, and this is great for either a small room where you want a wide field of view to pick up people quite close to the camera. So the 110 means 110-degree field of view. This has got a 4K sensor, of course, and with it you can do electronic pan, tilt and zoom. So you can pan around that 110-degree field of view. You can get a 2x crop there, and you've still got genuine 1080p output, which is great for conferencing. And of course you can mount this anywhere you like. You can mount it on a ceiling, above a display, below a display, on the wall, whatever you need to do. Now you can combine that, or instead use one of these slightly higher end NC series, which are PTZ models. Okay, with these, the main distinction is really in the lens and also some of the hardware on the back. So here you can choose between the 12x80, that means 12 times zoom, 80-degree horizontal field of view. Okay, so good for a lot of different rooms. That's quite a decent zoom, but not as good at zooming in as this one, 20 by 60. So narrower field of view on the wide angle, but can go very, very far. all right? And this one also has 4K sensors, and they actually feature auto framing, same as the NC110. So all of these, on top of their optical capabilities, can also do digital zooming around faces. So for example, you could point this camera at a certain place, and then auto framing would get you the perfect shot based on who it's seeing in that shot. The other thing these PTZ models have is they do have an SDI output, and they have an HDMI output as well, if you want to make use of that on top of the network capabilities. But the great thing is you can mix and match all of these. So when we say you can add lots of different cameras, it could be any of these different cameras that we've talked about. And within a room, you might have an NC110 for a wide angle shot of a big room. You might have a few PTZ models dotted about, and maybe a 20 by 60 to have a really long zoomed in shot of maybe the CEO at the end of the table, something like that. And later on, we're going to mention Q-SYS Vision Suite, which automates all of this in a really easy way. So even for very complex rooms, you can automate the cameras based on audio, based on video. That's all running on Q-SYS. So there we go. That is video capabilities. We've now looked at audio for the meeting room. We looked at video. I think it's time that we did a little system design. Okay, so let's go back to our room and see what we're going to do. We're going to start by adding a switch. This could be actually any decent modern gigabit switch that you can configure. We're going to talk about Q-SYS switches later. Here we've got an NC model, and as you've just seen, this could be 1 or 2 or 3, doesn't matter. Very, very easy to change that. And let's see, at the table, microphones. We're going to have 2 NMT1s. This is a 10-person room, okay? And I think that 2 NMT1s, it's going to give you, what, 8 zones, 8 lobes, okay? More than enough, I think, to cover this entire room. Now, laptops sold separately, we don't do those. And here we've got some loudspeakers, okay? So again, with the loudspeakers, you might say, I'm happy with just 1 loudspeaker. Just give me 1 NLC4 in the middle of the room, no problem, you could do that. Or if you want a better experience, you could have 2 or 4. And again, we don't have to think about the amplifier, we don't have to think about that, we're just connecting stuff into the network. So to summarize so far, we've got 4 NLC4s, 1 camera, and 2 NMT1s. We've done our peripherals, now it's time to have a look at the core that can run them. So, Core Nano, Core 8 Flex. Well, these are very, very similar, all right? Let's start with the Core Nano. Core Nano here, this is for network-only audio I/O and control on the back. So if you don't have a need for analog audio, kind of like the room we just looked at, right? We don't really need it. And you don't need something like GPIO or connections to LEDs, switches, things like that. This is going to be a really perfect option, okay? It's got some local RS-232 if you need to control devices not on the network, but you've got then USB, choice of USB-C or USB-B for that bridging connection. And then you've got the network connections. And it's important to realize here that all of these smaller cores are the same in this regard. Here we've got 2 network connections. Now, everything can be done over LAN A, by the way. QLAN, AES67, Dante, control, everything can be done over LAN A. You might want to use LAN B for certain things, and we'll talk about that some more later when we get into more complex rooms. So what about the Core 8 Flex? Core 8 Flex, exactly the same processing, same everything, except that we also have flex channels, and we also have GPIO. Now, a flex channel is an analog audio channel. We've got 8 of those, right? What a surprise. The Core 8 Flex, 8 flex channels, crazy. So 8 flex channels, and each of those can be configured one by one to be an input or an output. And on the inputs, they could be mic or line in, with or without phantom power, so proper audio inputs, and then of course line outputs. And like I said, you can do that channel by channel. So this might mean that you have all of them be outputs, maybe that's what you want, or all of them be inputs. Or you could have 4 by 4 or 2 by 6 or 1 and 7, okay, whatever you want to do, you can do it without having lots of different hardware SKUs to choose between. And with both these cores, they're half a rack unit. And you can see here, you can mount them anywhere you like, okay? You can mount them on the wall, on the ceiling, under a table, or of course you can rack mount them. And all of the hardware is included for that, by the way. So don't worry about having to spec different mounting kits, it's all included. Let's just look at some numbers for this core right now. So if we look here, Core Nano or Core 8 Flex, same in almost every regard, except if you look at the local I/O, we can see that the 8 flex channels, GPIO, that's available on the Core 8 flex. But they both have RS-232 and USB. Both have 2 LAN ports. Now, here's some interesting stuff. These have a peripheral limit of 32 peripherals. So that includes touch panels, cameras, NL loudspeakers, okay? All the other peripherals we're going to be looking at, they all count against that. So you've got 32 maximum there. These cores can actually be expanded, and we'll talk about that later. But for now, let's look at this here. 64 channels network audio I/O, okay? That's going to be more than enough. Maximum 32 Dante channels, okay? They include 8 Dante channels. If you want to upgrade that, you can with software. And then here we've got echo cancellation. I said at the start that echo cancellation is one of the more resource intensive audio processes, and that also goes for the NMT1, right, the microphone, because of course we are going to be doing some processing on that. So here we can have 8 channels of echo cancellation for third-party mics. So for example, that could be 8 Dante mics or 8 analog mics, for example. You could do 8 channels of echo cancellation on those, or /and, because you can actually mix these, you can have 3 NMT1 microphones. Remember, each NMT1, 4 channels, 4 90-degree beams, okay? So actually 12 channels of NMT1 or 8 channels with third-party mics. We can basically squeeze a bit more out of the NMT1 because of course we control that end to end, including even the beam forming. Now, these categories that you see here, AEC or NMT1 limitations, peripheral limits, and of course physical I/O, these are going to be some important things to check when you're designing systems. You're going to want to look at what peripherals you have and then see what core is going to be best to manage all of that. Now, right now, we're completely fine, okay? But as we get into bigger and bigger systems, that's when we're going to need to look at different cores to handle that. So coming back to our room, we're just going to add in a Core Nano there, all right? Chuck that in. And let's see how it all connects, okay? Because of course, this is really the straightforward part. We haven't talked about content video yet, have we? So in this example, actually, we are just going to be using my least favorite thing, a long HDMI cable. Oh my God. But then we've just got the USB connection for bridging. And now everything else is going to be just data, okay? Data for the core, data for the mics, data for the loudspeakers, and of course data for the camera. And we haven't really covered control in detail yet either. We'll do that in a second. But the touch panels as well, those are also a single data connection, which we can get onto later. So there we go, right? Really easy to design. And the cool thing is that now if somebody said, do you know what, I want that room to be 50% bigger with 3 cameras. You as a designer, you can just go, okay, well I'll add in 2 more loudspeakers, I'll add in 1 more camera. That's it. Check that you've got enough switch ports, right? End of story. If they want it to be smaller, 1 speaker and an NC110 instead of that camera, same deal, all right? Because the infrastructure for this is all networked, and because we know our core can handle stuff at this level, we can change this, we can play with it, and we're not gonna have some device in the middle that needs to be changed or swapped or extended or whatever. It's all just gonna keep working. So there we go. Let's just check everyone's very happy in the meeting room. Yeah, cool. Looks like they're all good. That's great. So wonderful. Let's pause here. All right, we've designed our first room. We're going to take a quick break. Then we're going to come back and talk high impact spaces. We're going to cover control, video, and a bunch of other stuff as well. So see you in 5. All right, we're back and it's time to talk about high impact spaces. Now here, we're going to focus on control and also video distribution, but we're going to learn about a few other topics as well. Now, a high impact space, that could be something like a divisible room or a lecture theatre or a multifunctional auditorium if we're dealing with a corporate AV space. So we're going to check some of those out. I want to start with Q-SYS control here because Q-SYS control really is fundamental to Q-SYS and we need to make sure we understand it. We're not going to be talking about additional processing hardware here because of course the core is doing all of the processing and every single Q-SYS core now includes every Q-SYS control feature. Okay, so every core that you go with is going to support everything I'm about to show you. Now with Q-SYS control we say firstly that it's integrated because it's built in. Okay, we don't have to add it in, which means less hassle programming things and also easier to specify because it's already in your core. It's also simplified because Anybody can learn how to program systems with Q-SYS control, and it's also very easy to understand what it's capable of and what third-party devices are most compatible. And it's also scalable. So even though it's very simple to start working with Q-SYS control, there is a huge tool set of very advanced capabilities that you can make use of, but also because we have that Intel architecture that every Q-SYS core has, even the lower end Q-SYS core has a huge amount of processing capability for control, and that only gets bigger as we go into the larger Q-SYS cores. And lastly, we say it's open because anybody can download the software, anybody can take the training and start to work with it, and basically we don't limit it. If it can be controlled, Q-SYS can control it. Now, let's talk about that integrated element first. We already understand this from earlier on, but typically we're going to be adding in a control processor, and that's going to mean a lot of extra tie-ins to all these other devices, okay? There's no kind of single device which is in charge of everything. This is in charge of the audio, this is in charge of the control, and this doesn't even mention what's going on with your video routing. Of course, with Q-SYS, this is going to mean it's all under one roof. So from a programming standpoint, but also from a design standpoint, we don't have to think of these things as separate entities. Let's talk now about some of the things we can do with it. So firstly, user control interfaces, okay? Here is the drag and drop UCI editor. And this is what we said about it being simple, right? Within that Q-SYS Designer software, which we saw earlier when we looked at the cameras, we can open up any of those components we saw, take any control from any device, whether it's a software device or a hardware device, and we can drag it onto our touch panel editor, and with no program experience, no coding at all, you can design a very pretty user interface that can do whatever you want, and then it's easy to deploy because we don't have to configure the touch panel. We just run that design on the core, tell it what touch panel we want the UCIs to be on, and the core just handles that deployment along with firmware updates and everything else. Really, really painless, really easy. But like we said, it can become more scalable. So actually we can use more advanced technologies like CSS and the Lua programming environment to make more complex user interfaces. And you can see a few other examples down the left-hand side there. In terms of what you're going to be deploying this on, we have the TSC series, okay, touchscreen controller. Here you can see there's a 7-inch, a 5-inch, a 10-inch, and all of these can be mounted on the wall. They can all be table mounted, as you can see here. Okay, and these all work in the same way. So like we just said, if you're deploying a UCI, it works the same way across all of these. They also have some handy features like built-in LEDs, like the soundbar, like the microphone, so we get nice color sync when we do mute sync between these devices. But something that's pretty neat is that also you can deploy UCIs onto iOS devices, onto Android devices very soon, if you're watching this in June 2025. And of course, actually any device with a browser. And there's also a dedicated Windows app. So all of this unlimited user interface deployment available with every system. Now, that's talking about user interface, but how do we interface with third-party devices to control them? Well, again, it's simplified and it's scalable. So really, it's choose the way you want to do it. All right. As designers, we don't really need to know all of this, but it's important to understand what's actually happening here. So firstly, you can do no code, low code, or full code. This is what we mean when we say anyone can start. Anyone can make use of no code and start to modify their designs or program a Q-SYS without any code. All of your native Q-SYS devices work in this way. You don't have to do any programming to make these work. It's all done with that friendly user interface inside Q-SYS Designer software. But of course, there's Q-SYS plugins for third-party products. And I just want to show you a slide which has a lot of partners on it. Okay, this isn't even all of them. There's more all the time. These are what we call technology partners. And with these other manufacturers, they have official Q-SYS plugins. Now, a Q-SYS plugin can just be dropped into your Q-SYS Designer file, and just like a native Q-SYS device, you've then got drag and drop, plug and play control of that device, whether it's a screen or a wireless sharing thing, or a video wall processor, or a third-party loudspeaker, whatever it might be, you're going to find Q-SYS plugins for those devices. So that's going to be the easiest way to work. What if you don't have a plugin? What if it's some other device that there's no plugin for? Well, then you can start to code, and you can do that using the block controller, which is like a still like a no-code kind of workflow. You're not actually typing out code, but you are doing the same logical things, but you're building it with these blocks. Apparently that's how they teach the kids to code these days. I wouldn't know, I'm much too old. And of course, if you're what you might call a proper programmer, you can go and use the full Q-SYS scripting environment using the Lua programming language, which is an open source language designed to be embedded into larger systems, just like Q-SYS. And that's actually what Q-SYS plugins are written in, but you can choose to write your own right there in Q-SYS if you want to. So there we go, we've got those technology partners. We've also got a whole community for developers, for Q-SYS programmers. So if you are interested in learning more about control, definitely check that out. Basically this whole open industry standard way of interfacing with other devices from a control perspective. Okay, so there we go. We're going to be all good for control. Most things are going to be controlled via the network, and of course we have those RS-232 ports if we want to control some devices natively without that network connection. We can just connect to them directly. So there we go, we've looked at control. Now what about video distribution? Another really important thing for high impact spaces, because we're probably going to want multiple sources, multiple displays, and maybe the ability to do some clever things with the video distribution there. So that's where we're just going to talk about another category of Q-SYS peripheral, okay, which is going to be this. It's going to be the NV series. Guess what it stands for? Network video. It's easy, okay? Now, with the NV series, some of you might start to think, okay, so this is the video part, there's going to be a different kind of system for video. I don't want you to think of it like that. It's not like that. Remember we said at the start that all Q-SYS peripherals follow the same rules. Now, as a designer, you need to be thinking, what peripherals do I need to add in to interface with the outside world? I want to interface with HDMI, with USB-C, to a display, to a laptop, that kind of thing. Just like you might add one of those QIO devices for an analog audio interaction. Here we're adding an NV device for video. All these Q-SYS peripherals, they're all working in the same way, they're all reading from the same hymn sheet, as they'd say, and that means that you're just choosing the right peripheral. Video is not some different special category of peripheral. Now, we've got here a few different boxes. We're not going to go and talk about all of these, but I am going to talk about this big one, because that kind of covers almost everything that we can do with NV, and we're also going to talk about that one there, the NV21, which is like its smaller brother, okay? This is the NV32H. Let's take a look at this. Now with the NV32H, this is designed to be a sort of one-stop shop for all kind of things you might want to do with video, while also including USB bridging and a bunch of other features which we're going to get into. It's a very exciting piece of hardware that does a whole lot of stuff using, of course, software and all of its processing power. All right. Now, there's a lot of stuff on the screen here. I just want to point out the fundamentals. This can be an encoder or a decoder, as you can see up there. All right. Now, as an encoder, we've got these three HDMI connections. That's why it's called NV32, right? 3-2. 3 inputs, 2 outputs. So I've got these 3 inputs. Now, like it says up there, I can encode one of those at a time at 4K resolution, up to 4K 60, 444. And I can seamlessly switch between any of them and be encoding one of them onto the network. But, and this is almost my preferred way of using it, if you're not so fussed about 4K, you can encode 3 streams simultaneously at 1080p. So you can have 3 sources connected here. All of those are getting encoded completely independently, 3 completely different streams going onto the network to do with whatever you want, to go to any other NV devices for a decode. All right. You've also got an output for a confidence monitor if you're encoding. Now, you can just switch modes, okay? So every NV you have in your system, you say this is an encoder or a decoder. If it's a decoder, it's the same kind of idea. You can have one decode, one display at 4K, or 2 decodes at 1080p, okay? So 2 independent monitors, completely separate decoders that can switch between any of those network sources, okay? We've also got USB, so that's your USB bridging. Same thing that we saw on the core. Okay, so whatever is happening with the HDMI, completely independently, the USB is decoding cameras and doing audio bridging as well. And there's a few other things here we're not going to get into right now, but we might come back to it later on. Now, as an encoder, like we said, you could have these three sources here and a single display there, and those three sources going off to the network. And as a decoder, you can have two displays, and each display can independently switch between any of these network sources and also any of these local sources, like as a kind of local 3x2 switcher plus decoding. Okay, so a whole lot going on just with one product, which is really what Q-SYS is all about. One piece of hardware that can do a huge amount in software. Now, how can we bring that into a room? Well, here we can see a pretty straightforward room. We can have a single NV32 there under the table, and with that we could connect a laptop. Okay, so here we've connected the laptop with HDMI and with USB, right? So there we've got some USB bridging going on. It's going to be receiving the cameras and the audio, and we're encoding the laptop's content. But let's say this is a slightly larger room now. Maybe we want multiple HDMI points on the table. That can just be one NV32 under the table. So we can actually have three HDMI points on the table, maybe spread out, but in the background there's just that one box. Now, let's say we've got even more sources, okay, in this kind of slightly bizarre meeting room slash presentation space, lecture theatre hybrid that I've made just for the purposes of this training. So over here, we've got maybe another laptop, we've got a document camera, and we've got another PC, and we've got over there two displays, right? So now I could have a decoder, and that decoder driving two displays, decoding two at a time from the table, and or switching between any of these sources on any of those two outputs, and doing USB bridging here, right? So the cool thing about NV32 is that just with two boxes, I've now got a 6x2 HDMI video matrix, and I've got USB bridging in two locations for audio and video, right? That's why NV32 is really great. Now, you might say though, with some justification, but James, most of my rooms don't need 6x2. Most of my rooms need maybe fewer inputs, one display, maybe two displays. I don't always need six inputs. Absolutely, fair enough, okay? So with that, we're gonna come back to this, right? NV21. So NV21, essentially the same concept, but smaller, much smaller actually. Again, doesn't look like it right now. And U standing for USB Type-C. Okay, let's put these two side by side. Now, actually this image, it doesn't really do it justice. So obviously the NV21 is smaller. What this doesn't show you is that the NV32, the depth is the same as a Core Nano or a Core 8 Flex. So, you know, it's reasonably deep and it's half a rack unit and it's doing a lot of stuff. NV21, obviously you can see it's like less tall and it's less wide. It's dramatically less deep. So I reckon the volume is probably a quarter of what you have on NV32. Now, you can see here the same basic idea. So we've got 3x2 on the NV32, and we've got 2x1 on the NV21, okay? We've got here USB-C input, HDMI input, two inputs, and then we've got one output, and it's the same basic idea. So as an encoder, you can encode two simultaneously, and you can have a confidence monitor, and then there's just one output. So the decoder can always do 4K, but it can also switch between these local sources. The cool thing is one of those inputs is USB Type-C, okay? So you've got the HDMI, you've got the USB Type-C there. The cool thing about that USB-C is it can do USB bridging for the cameras and the audio, and it can do content encoding, and it can do device charging up to 65 watts, all right? So this is a very flexible device, great for bring your own device because you've got that single USB Type-C connection, which, let's be honest, is what we all want. And if your laptop doesn't support USB Type-C, get a new one. Now, we've also got here USB-A. I'm just going to mention this real quick. All of the USB-As you've seen so far, actually, the ones on the cores that we've seen, these ones, they support a number of different things. They support USB audio hosting, so you can plug in like a little audio interface if you want, or a USB headset adapter. But they also support keyboard, mouse, and touch. So with that USB-A port, you can actually connect, let's say, a touch screen, and as you touch that screen, we're going to route those touch coordinates back to a PC connected somewhere else on a bridging port. So you can actually do KVM switching with all of these devices as well. That's just built in. Quick note on power. Both of these are PoE. Okay, PoE here, PoE there, but slight differences. All right, NV32, very, very powerful, lots going on. It requires the 90-watt PoE standard, which I think is Type 4. Okay, 802.3 BT, I think. I know that because I looked at Wikipedia before this presentation. Now, that's cool, okay? A lot of the AV line switches, they all support that now. And if you don't have 90-watt PoE, no worries, because you can just use a 48-volt, 1.5 amp power supply, which you can get from pretty much anywhere, right? NV21, 40-watt PoE++. So it's still PoE++, but it's the lowest version of it, 40 watts. But that doesn't include device charging. So if you do want device charging, you're definitely going to need the power supply, which we also sell as an accessory, okay? I think it's something like 12 volt, 9 amps, something like that. It's kind of a slightly odd specification, so you probably want to get that from us. And if you don't have PoE, again, the power supply can do everything. But just want to point out, if you need device charging, you definitely need the power supply, okay? So there we go, all right? And then we've come back to this example here. Same thing, I've just put an NV21 at the table, USB-C connection, and remember that's now doing charging and encoding of the content and decoding of cameras, USB audio bridging as well, okay, with that NV21. Cool, so there's the NV series. We're going to be coming back to that because there's more to come from NV series. But you can see, of course, how you could scale this up, how you could have lots of encoders, lots of decoders. Now, before we do our room design, there's one other thing I want to mention, and that's around audio. You see I haven't got any loudspeakers in this room, and that's because when you get into these more high impact spaces, you could certainly continue to use the NL series, right? Absolutely. But the thing is, if you needed, say, 8 NL loudspeakers in a larger room, there's no technical problem with that, but it might not be the cost-effective method if they all want to be playing the same audio. If you say, hey, I just want a single channel of ceiling speakers and they're all playing the same thing, yes, you can do that with NL, but then you've got 8 runs back to the switch, right? So not the most cost-effective way of doing it. That, by the way, is very cost-effective if you're doing like a mix-minus audio system where you do want individual channels. Actually, then NL is the best thing. But if you want a single channel, you're probably better off using passive loudspeakers and an amplifier. So let's talk about amplifiers. We've been making amps for over 50 years. Okay, that's what Q-SYS, QSC started out doing, was making amps. We've got very high channel count, high power amplifiers, but here we're just going to talk about the SPA-Q, small power amplifier, Q for Q-SYS, okay? Because even though this is an amplifier, completely new category of product that we haven't talked about yet, this is just another Q-SYS peripheral. So all the same rules apply. So here on the back, we've got a single network connection. Okay, that's where we're going to be doing QLAN, we're going to be doing audio to the amplifier, and this is available in 2 or 4 channel models. Okay, this is the 4 channel. You see you've got 4 outputs here. Now, whether it's 2 or 4 channel, you've also got flex channels and you've got GPIO. Okay, actually, let's just quickly go back to NV as well, because if we look at the NV, there's some analog audio on the NV32, right? How does all that work? Well, actually, any audio pins that we have on a peripheral, from the core's perspective, it's the same as if it was on the core. Okay, so these act a bit like they've got a QIO inside them, right? Like they've got an audio input and output breakout box, just as a little add-on. Okay, now this is great. Imagine you've got a core nano, you've got no flex channels, you've got no GPIO, and that's fine because you designed the system that way. But when you add an SPA, actually, it can be nice to just have a little bit of headroom and give yourself just 2 flex channels, not to the amp, but to the whole system. So anything you wire in here, or wire out of here, because they're flex channels, that just becomes available to the Q-SYS, not to the amp. The amp is just the vehicle for delivering that, all right? Same with GPIO. It doesn't matter if the GPIO is on the core, on this amp, on an NV, on something else, it's all just GPIO to the Q-SYS system, and it's configured in the same way in the Q-SYS Designer software. So of course, we can use this with 4 channels like this. It's also worth pointing out that you can bridge some channels and you're going to get some slightly different performance, which we'll talk about in the next room design. So, what are we going to do? We're going to do this. We're going to do a divisible room, okay? And this can be kind of a complex thing to accomplish if you do it in a kind of traditional AV sort of way. Here we've got 2 rooms, all right? And what I like to do with divisible rooms, rather than thinking of them as two rooms that we're kind of pushing together with like two processors, we're not going to do that, okay? We're going to think of these as one big room that's kind of got one core, but actually we can split it up. Again, everything's software definable, right? Rather than physically defined. So two rooms. We've then got bring your own device and an in-room PC in both rooms, okay? So maybe that's going to be tricky. We're going to have table microphones. We're going to have two cameras in each room, so 4 total. And of course, that needs to work so that 2 cameras go to one PC. But then when the rooms combine, we want the 4 cameras to go to any PC, right? That could be really tricky. It's not going to be tricky, but it could be. We've got 2 displays in each room, 4 displays total. So same idea, right? We might want to have our PCs only go to the displays in the room, but when the rooms combine, any PC can go to any display. And ceiling speakers, but also column speakers, okay? Now, by the way, we make a huge range of loudspeakers, which I haven't covered here. We're going to be covering that a bit more in a future training, but we are going to make use of some of those in this room. So let me show you how easy this is going to be to design. We're going to start off with just half of this. We're just going to start off with one of the rooms, okay? Let's call it room 1. And tell you what, we just did SPA, so let's start off with the loudspeakers here. I've got my network switch, and here I've got an SPA Q. So this is going to be driving my loudspeakers. And we said we want column speakers and ceiling speakers. Now, because this is the 4-channel SPA, I'm going to take 2 of those channels, and I'm going to take them off to the ADS802T. So this is actually a column speaker, okay, with 8 drivers, and it's also got a transformer, means you can use it with 100-volt line. But here we're just going to run it in low impedance. All right. Now, the cool thing is I'm going to bridge the 3rd and 4th channel on this amplifier. We can combine those together, and now we can drive a whole long run of ceiling speakers or pendant speakers in this example. So that's cool. And then just a single network connection to the amp. Let's add in everything else. Okay, so we're going to bring in here our NV21. We've got that at our table for bring your own device. We've got USB-C connection, microphones, touch panel, cameras, okay, so now we're just adding the peripherals that we need to make everything work. And at the display side, we've got 2 displays, so maybe we want to have an NV32 decoder there. And we've also got an in-room PC, which can go to those local displays. Also, that's got USB bridging on it, and we've got USB bridging here. So you can see, so far, we've got an amp, and we've got 2 NVs. That's kind of doing all of that I/O and routing, and everything else, all these peripherals are just coming in as sources or destinations to that. Now that's it, right? That's one room done, and now we're just going to add in literally a copy and paste. I've literally just copied and pasted this in PowerPoint, okay? Now, this is doable because everything's going back to the network, right? So all of this, physically, there's nothing that says that this has to be 2 separate rooms. Physically, you can just think of this as one big system, but in our configuration, we can set rules about what can be routed where. Okay, so in the software level, that's where we're going to be able to define it, that when the room is open, when the room is closed, the camera routes are going to change, the camera routes are going to be locked on the touch panel, the UCIs are going to change, all of that stuff, okay, completely fine. Now let's add in our wall, again, sold separately, and maybe we want to have a sensor for the wall. Now, we don't make our own wall partition sensor, but you can use pretty much any of the ones that are out there that work with a contact closure, like a little relay that's going to trigger when the wall opens or closes. Because, of course, remember, we've got that GPIO connection on the SPA there. So really easy for us to just, hook that up to the SPA. And like I said, it doesn't matter that it's hooked up to the amp or to a core or to an NV, just GPIO, and that's the same for the whole Q-SYS system. Doesn't matter what device it's on. But you might have noticed something missing. Haven't got a core, have I? I haven't actually got a core in this system. And that's because this is a great opportunity to talk about the limitations of what we were using before and move up to something bigger. So here's that thing we saw earlier when we did the Core Nano and the Core 8 Flex. Okay, we saw some of these specs here. Now, the thing that's going to trip us up here is this. We want to have more than 3 NMT1s. I've got 2 per room, so 4, so 3, not going to work. Okay, it's just not going to work. Okay, so what are we going to do about that? Well, if we look at our Core Nano here, we said earlier on, that could be considered 1x processing, and then the other cores are increasing on top of that. Okay, so our next level up as a hardware jump is going to be to the core 24F. Okay, now that has 4 times the processing power, give or take. Okay, so that will definitely do this divisible room, no question. But it feels a bit annoying in this case because actually everything's fine except we just need one more microphone. All right, so that will work. But for that reason, we can actually add in a software feature onto the Core Nano or the Core 8 Flex to actually expand without spending as much money as going up to the next level of hardware. And we can add in the scaling license and it basically doubles the processing power. Okay, so this is great. Rather than us making another hardware SKU, actually any Core Nano or Core 8 Flex can be upgraded with software to come into this kind of midpoint between the base level and the next level up, the Core 24F, which is exactly what we need right now. So that 2x processing, okay, that applies to network audio channels, acoustic echo cancellation, general DSP power, NMT1 count, that's what we need right now, VoIP channels, goes from 2 to 4 VoIP channels, and also streaming media, for example, internet radio stations, things like that you can actually pull in with Q-SYS as well. And we go up to 48 Q-SYS peripherals from 32. Okay, so if we bring that into this spec sheet, you can see here with the scaling license, we've now got a lot of things upgraded. Note, by the way, that you can't add more than 32 Dante channels. Okay, that's the same regardless. So coming back to our design, we'll just use a Core Nano. Okay, not connected to anything other than the network, and we'll add in the scaling license, job done. Great job. So there we go, designed our divisible room. Now we're almost ready to go on to even bigger and better things. But before we do, I want to quickly go back to the NV series, okay, back to the NV32H, because I mentioned there was a few other things we didn't really cover here. And that is that the NV32, because it has all this power for encoding and decoding and bridging and all of that stuff, we actually have another mode. We've got the encoder mode, we've got the decoder mode. We've got a third mode, core mode. All right, core mode. Now, how does that work? Well, it's pretty straightforward, okay? This isn't an optional feature. This is just something that every NV32 has the ability to do. Now, let's talk about how it works so far, okay? We've been talking about it as a peripheral, a Q-SYS peripheral, and in that mode, you can encode or you can decode, right? You've got those 2 ways of setting it. But you can reboot the NV into core mode. And in core mode, it's a lot like something like a Core Nano in terms of processing power. You could say it's got 1x processing. And of course, this is alongside local switching and USB bridging and the other I/O, things like the audio I/O, stuff like that, that remains the same. Okay, so let's now say, all right, we've got this new core, NV in core mode. How does that compare? Well, it's like this, okay? So I've put the NV over here because it's slightly less powerful, but not really by much, okay? And here we've got, of course, a lot of interesting I/O. So whereas the Core Nano limited I/O, which is almost, part of the appeal for some systems, the NV32, we've got, of course, 5 HDMI connections. By the way, all of those, you can embed, de-embed up to 8 channels of audio on all of those at the same time. You've also got the 2x2 analog audio connections, okay? There's 2 TRS connections there. GPIO, RS232, USB bridging, 2 LAN ports, same peripheral limit, okay? Slightly less network I/O, okay? So it can do 64 ins, but 32 outputs on the network. Same Dante. Now I should say it doesn't include any Dante, okay? Because it's sold like as a peripheral, you can change it to core mode, but you can purchase 8, 16 or 32 Dante channels. And then the AC and the general DSP, very, very comparable, but 2 NMT runs rather than 3, okay? So you can see it's roughly about the same processing, not exactly, but for many systems, that's still more than enough. Let's look at a small system here. Let's say this is like a small meeting room, all right? And here I've just got an NV32 in core mode, and I'm doing a huge number of different things with it. So over here, we've got HDMI switching. right? I've got a PC with 2 outputs going into that NV. I've got a wireless sharing. Maybe it's something like ClickShare, or maybe like Immersive Solstice, something like that. So 3 inputs going in, and then I've got 2 outputs. So 3x2 switching. While it's doing all the audio processing from these microphones, it's the control processor. It's dealing with probably that wireless sharing box, controlling it. It's also got a user interface, and then we've got sound bars, we've got an NC110 camera, and we're doing USB bridging as well. I mean, there's a whole lot going on just on an MV32 there. That's great. Now, of course, you'll notice that I can't do encoding, decoding of HDMI while doing the core mode thing, but actually you can bring that in. Okay, we've been talking about how it's either or, peripheral or core mode. But imagine this kind of situation, right? You've got a room, you've got a system, and it's got an MV32 in there, encoding or decoding, either way, okay? And then you need to add in a core nano because you need a processor, okay? And obviously that has a cost attached to it. But for a lower cost than that, you can actually add in a software feature which lets you do both. So any of the MV32 in your system, you can make it a core, and you could have it be encoding or decoding at the same time, okay? This is called the video streaming feature license. You can add this in instead of buying something like a Core Nano for the rooms that are gonna work with that. So now if we come back to this conference room, exactly the same. It's exactly the same, except I haven't got the wireless sharing, and now I've got an MV21 instead, okay? So we're going to get significantly lower latency streaming, but also now we've got USB-C and we've got bridging at the table, and that NV32 over there is decoding that while it's doing everything else, right? That's fine. So it's doing core mode and streaming. But you could do something completely different, right? Look at this system, completely different. This is like a lecture theatre, and I'm actually going to zoom in on this for you because this just shows you how far you can go with this, right? Over here, I've got an MV32 encoder with the streaming license. What is that doing? Well, it's doing some USB bridging to an installed PC. I've also got HDMI going into it from the PC and from a laptop. All right, we've also got some bridging happening between the laptop and one of our TSC touchscreens. So you can optionally do USB bridging on that, just worth pointing out. We've got a confidence monitor on the NV, and we've also got it receiving some wireless microphones, controlling a higher channel count network amplifier. Okay, a lot of stuff going on there. But in the room, what have we got? Well, we've got MV21 decoder for the projector. I've got delay monitors, so I've got 3 MV21s there. I've got a bunch of loudspeakers coming from the amplifier, 2 third-party ceiling beamforming microphones, and a bunch of cameras. What have we got? 1, 2, 3, 4 cameras. We've got a QIO for control that's doing serial ports, and we've also got some column speakers there. So all of that running on a single MV32 in core mode with streaming as well. Okay, so make sure you remember the MV32, very, very powerful. When you're working within the limitations of the processing there, that 1x processing limit. All right, hope you'll agree, very, very cool. So there we go, high impact spaces, lots going on. Okay, now we're about to move on to some more advanced systems. We're going to talk about multiple networks, talk about cloud, and talk about when we really do need to go to some new core hardware. So let's take 5 minutes and I'll see you back here for section 4. Okay, welcome back, and it's time for the next section, Advanced Systems. And the system we're going to be working on here is going to be a slightly more complex space. It's going to be something like this, an all-hands space. Okay, let me get out of the way so you can see the kind of thing you're going to have here. Now, these kind of spaces, particularly in the world of corporate AV, really have to do a bit of everything. Okay, it's technically a conferencing system because this is going to be used to do broadcasts and webinars, and we're going to have far end somewhere. We're also going to be using it for obviously announcements, but it's also really like a performance venue, a live venue. So the requirements for these can be quite stringent because it really has to be able to do whatever it is that you want it to do on a particular day. So for example, if we talk about input output first, just talking about requirements, you're going to want probably a bunch of ceiling array microphones so that you can pick up the whole audience for Q&A, and so you can also pick up that presenter. But Many presenters might want a wireless lapel, maybe one like this, and maybe some of them will want a handheld. We might want a combination of that for multiple presenters. Also analog microphones for a panel discussion. Maybe we just have some wired microphones, and maybe there's something like an analog patch panel for anything else. You know, for the company party, the DJ shows up, just needs to plug in. We need to be able to accommodate that. Now, at this point, we're also going to look at cloud monitoring and management, because this really is a mission critical system for those kind of big company announcements. And also we're going to talk about network topology here, because in this system, because the system's so mission critical, the IT department have a thing or two to say about it. So we're going to look at that as well. Of course, with the analog mics and the analog patch panel, this is going to go way beyond what a Core 8 Flex can do in terms of analog I/O. So we're going to actually look at a core that can handle that. And of course, with this, if we want to have an IT network that's separate from our Q-SYS network and that's separate from our Dante network, we can't really do that with a Core Nano or a Core 8 Flex or an NV in core mode, because they've only got two network ports, LAN A and LAN B. Which brings us on to this, Core 24F. Okay, this is, as you can see, twice the size of the other cores we've seen so far. This is 1U, and significant jump in performance, but also in the actual flexibility of the hardware in terms of configuring networks and connecting it to other AV devices. Okay, so the main thing here is you've got the right capabilities for demanding applications like the one we've just seen. Okay, some of the headline specs that you might want to know about are the I/O capacity for the network, 160. Okay, so a big jump above Core Nano, Core 8 Flex, even with that scaling license. Double the maximum Dante capacity, and 50% more echo cancellation channels than those cores with the scaling license. Okay, and it's basically got double the general DSP performance as those cores with the scaling license. Okay, so if you can think of a Core Nano as 1x, scaling license roughly 2x, this is like 4x processing. Now, of course, we want to see the back because we're AV people. We don't care about the front of the product. Let's have a look at what's on the back of the Core 24F. Now here you've got a great deal of analog audio flexibility. Okay, we've got 8 flex channels, just like the Core 8 Flex. They work in exactly the same way. But in addition, we've got 8 dedicated mic line inputs and 8 dedicated line outputs. So of course, you could use this as 12 in, 12 out by using some of those flex channels. You could say that you want 16 in, 8 out, the other way around. It just gives you a lot of flexibility for all sorts of different analog audio use cases. Also GPIO, like on the Core 8 Flex. So again, this is great for connecting to switches, relays, LEDs, fire alarm systems, anything that's going to use some kind of low-level electronic communication. It's going to be great there. And then if we come over to the other side, we can see here that we've got the same RS-232 setup as those smaller cores. Okay, so we've got their 2 ports, just like on the Core Nano and the Core 8 Flex. USB-C for audio, USB and video bridging. And we've also got the USB-A ports, so much the same as those smaller cores. But now we actually have 4 LAN ports here. LAN A and LAN B, and also LAN C and LAN D. And there's a display on the front, which is nice. So let's compare this to the other cores in terms of those main important specifications. And we can see here, generally speaking, about 4x processing, okay? Lots of local I/O, that's really, really nice. 4 LAN ports, we're going to talk about that in a minute. 96 peripherals, so double what you see here, okay? 160 network I/O channels, up to 64 Dante channels. And here we've got 24 AEC for third-party microphones, or up to 8 NMT1s. It's important to notice, as you've probably seen, when I say 4x processing, it doesn't mean that all of these numbers are 4 times these numbers. And also, there's a lot of numbers that I'm not showing here just for clarity to keep it onto one slide. So if you do log into the website and go to the Q-SYS processing page, then of course you're going to see a lot more specs that we haven't really got time to go into right now. Let's talk about this, 4 LAN ports. Why? Why is that important? Why would we want 4 LAN ports? Well, let's look at some of the other use cases where you might want to break certain protocols away from LAN A. Currently, everything we've done has just required one network. So everything we've done so far has looked a bit like this. LAN A, and there we've got our QLAN, Dante, AES67, video, internet, VoIP, basically everything. Everything Q-SYS can do on LAN A. That's kind of the default, but there's many cases where you might want to break that away. Okay, so for example, we might want to have LAN B be connected to our enterprise network. Okay, now actually LAN A could be on the enterprise network, and you can run QLAN entirely through an enterprise network if it's configured correctly. But it might be that you want to have LAN A be an isolated AV network and LAN B just be the enterprise traffic, so internet, VoIP, maybe you talk to it with SNMP, I don't know, anything that the enterprise network needs to see. So why do that? What's the benefit of doing that? Well, if we do that, firstly, from an end user IT perspective, there's a couple of advantages and some disadvantages. All right, so this isn't better, it's just different. Why would you want to do this? Well, if you're the end user IT department, you might be quite comfortable dealing with all this AV, and you might be quite comfortable being, I suppose, on the hook for all of that AV working in addition to all the IT stuff you have to do. It is all standard IT traffic, so there's no technical reason why you can't do that. It just means that you need to configure the network in a particular way and add in some prioritization and a few other things. Okay, so this might be of interest because it means the AV integrator is responsible for that AV traffic. Anything to do with AV, don't speak to IT, go and speak to those AV people. They've set that up. They can help you with that. Okay, that might be something that the end user IT wants off of their plate. Also, it means no changes needing to happen on their network. So not only are they not responsible for it, but also they don't actually have to go and start fiddling around with the enterprise network. Now, again, this isn't the kind of default. Many customers actually design their enterprise networks for new buildings with AV in mind, and they actually want to do the opposite of this. Now, the other reason this might be of interest is that even with stuff segregated, we can still monitor and manage Q-SYS from the enterprise network and from the cloud. So that's good, okay? Feels like we can cover a lot of things here. The downside are definitely greater network complexity, and I don't mean that in terms of the configuration, I just mean physically having two separate networks can be a lot to keep track of, okay? Particularly if you think about a small room, if you just had like one room with your AV in it and you had one switch in there and everything else was the enterprise network, that would be okay, right? But if you imagine a whole building full of Q-SYS, have you basically got to have two entire building-wide networks? You know, that doesn't seem like a good idea, right? You probably want to converge them and just run everything on the enterprise network. For this reason, reduced routing flexibility. If you've got to build an entirely separate network, maybe that can't encompass routing things between rooms or routing things around the building, but if it's running on the enterprise network, it probably can. And of course, some end-user IT departments really don't like this, even if it's not on their network. They don't want to have different switch manufacturers that are not what they have on their enterprise network on the same site. Okay, can add to some confusion. So just a bit of background there as to why that might be of interest. And of course, what we're actually talking about physically is something like this. We've got our AV network with all our Q-SYS, and that would have Dante and other stuff as well. And then over here, independently, we've got the enterprise network where we've got all of the corporate services. And what we're talking about is we're taking LAN B from the core, we're bringing that onto the enterprise network so that it can reach internet and VoIP services and anything else, okay? But all of the AV traffic stays contained within here. Now, let's just talk about the network a bit more, okay? So Q-SYS uses standard IEEE protocols. Not all AV traffic, fits that description. Some AV traffic does require specific switch models and does require proprietary hardware. QLAN is fully IEEE compliant. It works through layer 2. It even works through layer 3 if you want to get into that, okay? All of it is routable, which is very rare in the AV space for real-time audio and video. It does work with a dedicated network or a converged network, okay? So there's nothing technical that says you need to segregate things. And any modern gigabit switch can be configured to work with QLAN. We do have some switches on our website that are like blacklisted, but most of those are very old, and I find that most modern quality switches work very, very well and meet the latency requirements in QLAN audio and video. You must configure the network with quality of service and IGMP snooping. And if you don't know what that means, don't worry about it. But there is also a network fundamentals training on our website where I go through this in quite a bit more detail. The reason that's so important is it guarantees the performance of the real-time traffic. So the latency requirements are quite stringent because it's a real-time audio system. We don't want to have any delays. And if there are delays, we're going to have dropouts, basically. So we do need to make sure these things are configured correctly. A quick note on bandwidth. Okay, again, we're going to go into much more detail on this on other trainings, but just to give you an idea, audio is not particularly high bandwidth. 16 channels of audio, 26 megabit per second, thereabouts, okay, roughly. So that means 512 channels of audio, which is the maximum we can do on the biggest Q-SYS core. That's, 850 megasecond. That's really significant on a gigabit network, but still fits within a gigabit, still okay when things are configured properly. Just so you're aware, video, NC series, the cameras, it's around 12 megabit per second. Okay, so not ridiculously high at all for a video stream. And then NV series has its own proprietary codec, and that's dynamic, so it depends actually on the level of motion in the video. Something that's got a lot of static content, actually like what you're watching right now, where it's mostly a still image and I'm moving around, you're going to find that somewhere in between these two numbers. Okay, even for a 4K stream, maybe that would be 100, 200 megs, something like that. And that's going to go up and down in real time depending on the content. Whereas if you play a full 4K 60 nature documentary or something, you're going to see it go towards that 750 number for that encoder in total. And then on the other end of the scale, completely static image, something like this, it will be around 20, 30 megabit per second, even at 4K resolution. So just bear in mind that with NV series, we're really interested in the worst case scenario being like this. So you need to make sure you're just thinking about that when you're putting NVs in a network, the bandwidth between them. Now, if all of that sounds like, something that you don't want to think about, if you're like, do you know what? I actually want to just have the network problem taken care of. We do also sell switches which are pre-configured for Q-SYS, okay, called the NS series network switches. Now this is actually Netgear AV line hardware. So if you haven't been paying attention, Netgear have been making some fantastic AV switch hardware and software for quite a while now. And at Q-SYS, we've been doing custom configurations for switches for a very long time. I want to say like 15 years. We've been doing this longer than almost anyone else in the industry. Okay, so what we have here is Netgear hardware, but with our configuration, which is completely plug and play. There's no need even to log into the switch and choose the Q-SYS option. You just take it out of the box, start plugging things in, it's all set up. Now, what is it set up for? Well, basically, you've got it supporting Q-SYS audio, AES67, Dante, video, control, third-party devices, all just plugged into the same switch in the same VLAN. It also supports PoE++ if you choose that option, so great for the NV series, and of course supports a lot of future Q-SYS products as well, because we kind of have this cohesive understanding of network traffic between devices. So that PoE++ is great. You can get these switches with 90 watt on every port, which means you could have a lot of NV32s, or of course NV21. And another nice thing, just physically, these come by default with rear-facing ports. So your AV rack with all the AV devices with ports on the back just all lines up, looks very good. Or you can mount it the other way if you want to. And when you're choosing these, it basically comes down to the number of ports you want. Do you want about 8 or 24 ports? And do you want PoE Plus or PoE++? Okay. And of course, with these switches, if you do then have a problem with the system, of course, then Q-SYS supports this the same as any other Q-SYS product. I should also point out there's a native Q-SYS plugin for this, so it does get monitored and controllable from your Q-SYS system as well, if you want. So there we go, a little look at some network stuff. Coming back to the Core 24, which kicked all this off with its 4 network ports. So how might that come together? Well, back on the Core 24F, we've got LAN A and B. Now this is the same as any other core. Every core has A and B. They support all protocols, okay? But QLAN only goes on to be if you're using it as a secondary network, as a backup network, where you actually have the option to mirror QLAN on LAN A and LAN B, okay? Otherwise, QLAN is always on LAN A. But Dante, for example, could go on A or B, and any other protocol could go on B as well. C and D, non-real-time only, okay? So what do I mean by that? It supports all protocols except for real-time AV traffic. So no QLAN, audio or video, no AS67, no Dante on C and D. All other traffic supported. So for example, what might you do? You could, if you were using all of these, have QLAN on A, Dante on B perhaps. Then you could have third-party device control on C if you wanted to segregate those. And of course, on D, maybe you put it on the internet, maybe you put it on the enterprise network, which brings us back to Q-SYS Reflect. Okay, we did say that this room does want to be fully monitored and managed using the cloud, which is probably something we want to do for any room, really. Now, we mentioned Reflect earlier on, but what I'd like to do now is just talk about it a little bit more, give you a bit more background about what Reflect actually is. Okay, because this is something you can use on absolutely any Q-SYS system. So what is Reflect? Well, Reflect basically works like this, okay? We have this concept in Reflect of a system. And any of the systems we've made right now, any of those cores and all of their associated peripherals, we call that a system. That could be one little room, or it could be this great big room we're working on right now, or it could be that divisible space. Okay, those are called systems. Now, as we know, locally, all the peripherals and the third-party devices are reporting up to the core, so the core knows everything that's going on. Now, what Reflect lets you do is you can then collect those into sites. So, for example, you might say, I'm a hotel and I've got this London site and I've got this New York site, and those have multiple Q-SYS systems within them. Okay? Then all of those sites report up to what we call the organization. So that would be Really Awesome Hotels Limited, something like that. Okay? And then if you're a support person, if you're actually running a support organization, maybe you're supporting multiple organizations, you could see multiple organizations. And it comes together like this inside your Reflect dashboard. So what Reflect lets you do is log in to your Reflect dashboard. You can see every organization that you're a part of, and depending on, of course, the permissions, which is set by the organization owner, you can then see everything that's going on across the whole AV estate. You can go down to a site level and see how a certain site is doing, and then, of course, you could go within a system in that site, and then you can even look at the state of every peripheral. And you can also load designs using the Q-SYS Designer software, and if you have the right permission level, even start to push firmware, make changes, tweak the DSP. Anything you can do locally, pretty much you can do through Reflect instead. Okay. Now, what's included with every Q-SYS system? Well, real-time health monitoring. So all the cores and the peripherals and the third-party devices, you can see just one massive assets table of everything that's going on there. Okay, you don't even have to look at it on a site-by-site basis. You can look at it for the entire organization. Remember that we talked about those Q-SYS plugins made with our technology partners. The vast majority of those are what we'd call Q-SYS Reflect Ready, which means that if you use those plugins, it's automatically made available in Reflect when you add that system to Reflect. All right. There's also a Reflect API, also included with every Q-SYS system. So if you want to integrate that with something like ServiceNow or some kind of IT help desk, you can do that not just for, product by product or core by core. You can actually make some API calls and get information about your entire organization very easy with no limits or restrictions on use. Now, I also want to point out this data flow is very simple. A lot of other kind of cloud systems, they have this thing where you either need to add an additional server on site that's monitoring things, or you need to add all the devices to the internet. And either of those could work, but it's a little bit intrusive, I might say. Okay? Whereas here, we already have this happening locally. Every Q-SYS system works in this way, whether you're using the cloud or not, right? The peripherals are always reporting to the core. That's just a given. So all we need to do to make Reflect work is actually just have one link from the core to the cloud. And that's just done using HTTPS over port 443, right? So no funny business. It's all just using the same communication that any kind of PC would use to get online. Also supports proxy servers if you do have a client where they're inspecting the traffic going out, for example. Now, this is a huge benefit because this is already happening, this local part, so the only thing you need to do is get it on the internet, and then you can make use of all this stuff with Reflect. There is also a Reflect Plus option, which includes a lot of write access, so you can actually make changes, bring up things like remote UCIs, and bring up that Q-SYS Designer remotely, which is hugely powerful. So that's it. We can actually use that with every system, but we're particularly going to use it right here in the all-hands space. Okay, so there's our Core 24F. How might we bring this together? Well, we're not going to go through the whole system design here. I don't think we need to do that, but just to give you a little bit of an example. We've got our Core 24F kind of in the middle. We have that network segregation going on here. Okay, so here we're going to have our QLAN devices, right? Lots of cameras, peripherals, loudspeakers maybe. We're going to have a separate Dante network in this case, okay? And there you're going to have, microphones, for example, going to be on the Dante network. We've got a lot of analog audio, so analog microphones, patch panel, of course, they can just plug straight into the inputs and the flex channels. And then we can have a third network for the enterprise, which is going to go up to Q-SYS Reflect, okay? And of course, we've still got that fourth network if we wanted to use that. So there's an example of how the Core 24F can enable some more powerful, more complex spaces. Now, one other thing you find in these kind of spaces is a need for presenter automation. Okay, if we're running these kind of live broadcasts, company town hall events, things like that, it'd be really great if the system could automatically respond to those kind of presentations. Now, something that we hear from the market is, well, stuff like this, for example. Okay, our executives get frustrated when remote participants can't see who's speaking. So, for example, an audience member asks a question, or someone's speaking on stage, or someone's moving around on stage, and the cameras aren't quick enough to switch. Maybe it's being run manually, or maybe there's some kind of automation, but they're missing those kind of reactions. So, wouldn't it be great if we automatically framed active speakers? Also with presenters, sometimes they have to stay in one spot to be seen, they have to stay on the lectern because there isn't some kind of camera automation. And of course, even if they have got camera automation, it might lose track of them if they're stuck behind furniture or if there's multiple presenters, something like that. So we mentioned this briefly earlier, but this is where Q-SYS Vision Suite comes in. Now, Q-SYS Vision Suite is something that you can add to any Q-SYS system, which adds a whole extra layer of video and audio AI. And the outcome of that is that you've got dynamic camera framing and room automation based not only on computer vision, but also based on all of the data from the intelligent microphones in the space. Now, here's a little animation that just shows the kind of thing you can do when you're adding Vision Suite to a system. Here's a room. This could be like an auditorium, perhaps. And we've got various cameras in here. And most of these are cameras that we might already be adding to pick up the presenter. Okay, a couple of cameras facing the area that the presenter is going to be in. And you can see here that we've got the ability to define different areas. So you can actually draw on the camera's field of view and set up different pickup areas here. Now, this means that when a presenter comes in, we're able to set up particular shots. We might say that we want to have that be a medium shot, like the one you see here. And if someone asks a question in the audience, that's going to be picked up by some beamforming microphones that are available from our partners. And then we can show them asking a question. Okay, so that's what Vision Suite is all about. It's about integrating the audio triggers and the visual triggers in a single holistic way. Now the presenter's moving around, you can see the computer vision detections on them there. And in this case, when they're at a whiteboard, we're switching to a dedicated whiteboard shot. Okay, so there's just some examples of what you can do with Vision Suite. We're not going to get into that right now because it's a very deep topic that can do a lot of different things, but do check out Q-SYS Vision Suite training, which is coming summer 2025. There's already a preview of it out there, and depending when you're watching this, the whole thing might be out, so do check that out. So we've almost reached the end of the training. Now we're going to look at centralization, which is something that you can do when you have particularly large systems. We're going to look at server cores that can manage a huge system in one place. Now, we mentioned this earlier. You've got appliance cores and we've also got these server cores. So far, everything we've looked at has been an appliance core. Okay, lots of nice integrated I/O, the form factor designed for fitting into a room. But As we go bigger, it might be that our cores are not in the room at all. They're actually located somewhere completely differently. Something like an IT closet, perhaps, with other IT facilities. So here, server cores and X-class cores, which we'll look at in a second, all about power and scalability, no local I/O, or very, very little, all delivered via the network, and an IT-centric form factor. What would you use that for? Well, let's have a look at this. Here's a little video showing a meeting room. Looks like they've got a Vision Suite there. But what if next to that, we've also got this learning space, which is also a divisible room? We could run those as separate systems, of course. We could have a core there and a core there, not a problem. And now there's also this employee area where we've got sound system and video system. That could be another core. You can see how we go through the whole campus here, and there's a lot going on. What if we've got something like this, right? Hospitality and entertainment. We might have outdoor spaces, VIP suites, performance spaces, a gaming area, okay? It could be something completely different, like a theme park, where we've got park-wide audio, but we've also got various attractions, okay? All of this could be run on lots of separate Q-SYS cores, but cores like this give you the option of running all of that in a single centralized location, okay? This is the X-class cores. Take a look at these. This is here the Core X10 and the Core X20R. And I'm going to break down what these cores do, and then we're going to talk about why we might want to centralize our processing, and also why we might not, depending on what we're going for, okay? So what is X-class? Well, as you can see here, these are the Q-SYS platform deployed on enterprise-grade servers. So fully networked I/O, okay, like we just talked about. Ideal for mission-critical services that pair with edge-based network I/O. That would be our Q-SYS peripherals. Core X10. Now, Core X10, this basically gives you about 3 times the processing power of a Core 24F. So what you might do with a Core 24F, you could do roughly 3 of those on a Core X10. Core X20 is about double the processing again, and that also gives you the option of hot swappable power supplies for maximum redundancy for those centralized systems. Now, when we're talking about centralization, we really mean that we've got a core somewhere central and the peripherals dotted around, a little bit like this. So here, rather than us adding cores in every location and deploying lots of Q-SYS systems, which you can do, instead you can use the network to scale up. So you can have a very powerful processor, and then in each room you're just adding in the peripherals you need. And then on that processor, you can either have those rooms be completely independent, completely separate, or you can have them all interact, maybe share audio, share video, completely up to you. Now, let's just talk about something very important when you're doing this, which is redundancy. In this example, I've got a lot of rooms relying on a single processor, and that's not an actual issue, but you might want a bit of extra peace of mind by having a backup processor. Now, the good news is that this is built into Q-SYS. This is actually supported on every Q-SYS core except for the except for the NV32 in core mode, all right? Because redundant HDMI, it's kind of a weird thing. So here we've got a core and we've got our peripherals, and this is what we've been doing the whole time, right? As we're talking about that information transfer between the core and the peripherals. As a designer, if you want to have a redundant Q-SYS core, all you've got to do is specify the same Q-SYS core, okay? And you need to make sure that any licenses, like Dante, for example, are the same on both of them, but basically just the same thing. And then you've got primary core and you've got a secondary core. Now, what happens when the programmer deploys the design is that the design actually goes to both of them. They synchronize together. The primary core is running the system as it would be if it was on its own, but the secondary is just monitoring that primary for a heartbeat. Basically, once a second, it's just saying, hey, everything all right? You still there? Everything good? Yeah, need any help? No? Okay, I'll just go back to sleep. It's just kind of in standby, and it's monitoring the primary. Now, if there is an issue with the primary, maybe it goes offline, maybe it loses power, whatever it might be, within a few seconds, the secondary will detect that, and it will just tell all of the peripherals that it is in charge, and then it will take over all of the audio processing exactly where it came off. And of course, the video and the control as well. That whole changeover takes about 5 seconds or so. with a bit of additional time if there's Dante streams changing over as well. But the core will also handle that for you too, which is nice. So just be aware that we can do that actually for any system, but particularly important for these larger centralized systems. Now let's talk about our options here. So centralized, that's what we're talking about, where we've got a central bit of processing and then peripherals and basically these spoke systems coming off that central bit of processing. What we've been doing so far is a core per room. Even a divisible room, let's say that's one room. Okay, so like a core per room, that would be what you call a distributed system, right? A little bit like this. So which one's better? Well, a bit like with the network topology, there's not really one right answer here, okay? Let's talk about some pros and cons. So if we have a look here at a centralized system, why is that good? Well, one cool thing is you can open up that Q-SYS designer file with all the processing, and you've got the entire building or the whole campus or whatever it is. You can just click around, making changes all over the place very, very easily. It might mean that you've got a lower processing cost, okay? Because even though your processors are more expensive, you've probably only got two of them, a redundant pair, right? Of course, as we've seen here, it's easy to add redundancy. Whereas in a distributed system, your cores are cheaper, but you've probably got a lot more of them. Okay, so that's something that's of interest. With a distributed system, okay, firstly, it's modular. All the rooms are fully independent. Now, let me explain that. In a centralized system, all of your rooms can be independent in terms of the actual outcome. They don't have to be sharing audio, they don't have to be sharing video. It can be completely segregated in terms of how the user experiences it. But they are still running through the same processor, okay? Here, they're obviously not. Now that means that if you wanted to firmware update a core or take a core offline or anything like that, you're not going to have to do that during downtime. Okay? If you want to do that here, it is going to result in downtime for that period that the core is offline. Okay? You could of course update a core, bring in another one while that's happening, all of that stuff. But here you could just take a room offline and none of the other rooms will even notice. Now, you probably have more cores, but that might mean that your core's I/O, for example, HDMI on an NV, or analog audio on a Core 8 Flex, or USB connectivity, you might need fewer peripherals because your cores have more I/O. So that might be a good thing. And you can still see everything in one place with Reflect. So it's not quite as easy to just make broad sweeping changes to everything, but you can actually take action and see the entire site, no matter what cores are actually bringing in that information. Now let's take a look at an upcoming Reflect feature, which is really good for showing you whatever's going on across your organization, whether it's centralized or distributed. So here we have something called Space Manager. And this shows you a map view of all different system locations. You can quickly look around, and that doesn't matter if they're centralized or they're distributed. You can have a flexible hierarchy where you organize systems by buildings, levels, rooms. And that means you can deploy support across a lot of different locations pretty intuitively. So that's coming this summer. And of course that works with any Q-SYS core, any system that's on Reflect. Now I think it's important that we do a little design example here to look at how this centralization actually comes out in practice. So here's a room we saw earlier. This is that NV32 room that we did earlier. Let's say I want a few of those in my new fancy building, which is going to have a few meeting rooms in there. So we're going to take this, we're going to say this is the new standard for our executive spaces. And we're going to have a redundant pair of Core X10s managing that, which, I mean, to be fair, there's a lot of extra horsepower in those X10s, but that's cool. That can easily manage that, maybe quite a few more as well. Okay, great. Now we've also got some other rooms, some smaller spaces. Here's an example we looked at earlier, which is the NV32 in core mode. Okay, where we've got the NV32 doing switching and the processing. And I'm going to put those in as well. And these are going to be my smaller spaces. Now, it could be that you say, do you know what? I actually really like the fact that these, it's all very neat. I've got my NV32. It's also the core. I could totally change all of those two peripherals and have them roll into that file there. Nothing wrong with doing that. That's completely fine. But it might be that you, as a designer, as an end user, say, you know what, it's kind of okay to have my smaller spaces be independent systems, or maybe do it the other way around. Maybe you want the bigger spaces to be independent because you want to be able to work on them more often, or whatever it might be. Okay, so this would actually be what we'd call a hybrid topology, and this is totally fine. We've got a mix of distributed systems and of centralization. Okay, that would look a little bit like this, right? Where we do have centralization, we have separate systems as well, and by the way, distributed systems can also share audio with each other, they can share NV streams with each other, and control traffic with each other. So if they need to let each other know that something's happening, or share some audio, share some content video, that's completely fine. All right, so there's a look at the kind of topology decisions you can be making for the largest systems. And let's also, at this point, compare all the cores we've seen so far with each other. A lot of numbers here. Don't worry about remembering all of this. But of course, you can look it up on the website later on. You can see we've added in the Core X10, we've added in the Core X20, okay? Huge increase in general DSP performance that you can see up the top there, all right? And also, no actual imposed peripheral limit on these. We normally say it's 256 peripherals and up, so we don't actually impose a limitation there. Now, there is also another core that we haven't looked at yet, because it's kind of like a Core X20R, but just even better, okay? That's called the Core 5200. And you can see there that has 512 inputs, 512 Dante as well, and also loads of AC, loads of microphones. Just, it's all about processing with the 5200. But all of these three are really the same category of product. It's just a question of power, how much you want, okay? So really that comes down to what we were saying earlier. We need to be thinking about what our designs require. Then we need to be adding in the peripherals that's going to facilitate that. And then we need to be thinking, okay, and what core do I need to facilitate those peripherals? And that's when we can come to something like this and just check that we're on the right track. So there we go, everyone. That's Q-SYS, okay? Hopefully this has been useful. Just to summarize, you've all seen Q-SYS is pretty simple to design with, because you've got this single platform, all right? Very, very easy to actually design large or small systems, because everything kind of follows the same rulebook. That monitoring really can't be overstated. The fact that everything locally is monitored just out of the box, especially when you're adding in third-party devices with plugins, and then all of that can be enabled through Reflect with a single connection. And Reflect is basically included for read-only. Okay, I mean, it's very, very, very important. Single platform advantage, of course. So one point of contact for consultancy, for training, for service as well. And of course, you can scale and save. You know, you've seen there, centralized processing minimizes hardware and programming costs, but also you do have the option of adding in those dedicated cores even with larger systems. So there we go. That's Q-SYS Architect Training, okay? And what's next? Well, there is actually an exam, okay? And yeah, to do the exam, you're just going to need to go back to the training website, log in for me, and once I mark you as present, I'm going to say all of these people attended, which I'll do just in a minute. You're going to see this option here. Click here to take the final assessment. It's just going to be about 10 questions, not too challenging if you were paying attention. And of course, if you need a refresher on anything, you can find even more information on our website. And I also ask you to check out the other training courses that you can do on training.qsys.com. Okay, thanks very much. See you later.